Hello, everyone. Welcome. Welcome to this webinar, I suppose we'll call it, on research integrity and responsible use of GenAI. It's, I suppose I say webinar, but it's actually a hybrid event because we've a great group of people here in the room, and we've a good few people online as well, which is great to see. My name is Sean Lacey. I'm the Research Integrity and Compliance Officer from Munster Technological University, and I'm joined here with
Tom Farley. So I'm one of the two co-chairs along with Anya DeRochta of the University's Research Ethics Committee.
Super, thanks very much. So we have a very exciting day lined up here first. But first, what I'm going to do is just give a small few housekeeping, I suppose not rules, but just points. So for people in the room here, in the unlikely event that there may be some alarm will go off or a fire, we have two doors here that we can exit. So if we go here, obviously we can go down to the left, or we go out that door, you go down to the right, and you can follow the signs there with that. This session is being recorded. So we will upload it afterwards to both SWORD, our institutional repository, and to YouTube as well. So will it be recorded? So it's I suppose it's just important that if you ask a question in the room, which we very much welcome, that you can, obviously you will be heard and will be recorded. Equally, there will be engagement with people online and people in the room to Slido, and we'll pop up a link to that there in a few minutes. I think, Tom, do you want to maybe give a small bit of background to this?
Yeah. So when accustomed as I am to public speaking, I said, you know what, I'll pretend to be professional and actually put together a little bit of a speech and just setting out the context and then just introducing our three speakers. So I mean, we genuinely really are delighted to see people here and online because it's an issue which it really is shaping the foundation of academic and research practices worldwide. I mean, there's no point in pretending that. And this technology, with its transformative potential, does offer opportunities to accelerate innovation, democratize knowledge, and reshape education and research. However, let's be quite honest, the rise also brings about profound challenges. And I think we're here today as a way of addressing our collective attention and thoughtful action and how we do that. It enables us to create, analyse and disseminate knowledge at unprecedented scales and speeds. However, at the risk of paraphrasing Superman, with great power comes great responsibility. As educators, researchers and stewards of academic integrity, we must ensure that this technology enhances rather than undermines the trust that society does place in us. We do. You know, if we don't want to, have a society where people don't trust the research, we need to face up to these things. Those implications are profound. For example, just one of the many things, consider authorship. Who gets credit for an AI-generated paper? Consider data integrity. How do we verify the integrity of the information in an era when we can fabricate data with ease? And what the broader societal impact in terms of environment and stuff? How do we prevent biases embedded in the AI systems from perpetuating inequality in research outcomes? Today's session is important because it provides a platform for us to address some of these questions collaboratively. It allows us to anticipate and mitigate risks and share best practices and propose possible strategies that ensure generative AI allows the principle of transparency, accountability, and fairness. It's very fitting that we are here in the architecture building because today we're not just participants, hopefully we are architects for future research. Together we have the opportunity to contribute to an academic culture where GenAI is a tool for insight and innovation, not simply seen as a threat to integrity. And I'm not for one moment underestimating those issues. But I suppose let's embrace this responsibility with open minds, critical thinking, yes, and a shared commitment to advancing knowledge ethically and inclusively. So that's, I suppose, some of our stuff here. Our three speakers here today represent a very good broad range. So our first speaker is Dr. Tomáš Foltýnek from Masaryk University in Czechia. I saw him present at the Integrity Conference in Athens, and I suppose it really struck me the importance of getting out and networking. I was blown away by him. He's brilliant, so no pressure, Tomáš. Like that. Well, you better be brilliant because I've told everybody you're brilliant. But no, as I said, he's the president of the board of European Network of Academic Integrity. He's the vice chair of the Bureau of the Council of Europe's Pan-European platform for ethics, transparency and integrity in education. So I mean, certainly someone who's going to give us a very broad and well-informed perspective. He is professor and assistant professor in the Department of They'll have the machine learning and data transformation or whatever. But I suppose he is the guy who actually knows what's inside the black box. I suppose that's the important thing, because we have 3 different viewpoints here. And as I said, what really struck me is that he takes that very technical stuff and makes it accessible and helps it to unpack. We have my colleague, Dr. Angela Wright, who actually was a former chair of the Research Ethics Committee, has done a lot of work in the area of GenAI and once again bringing that humanity to it and trying to tease out the things and in order to understand it. And then a friend and collaborator from the University of Windsor in Canada, Professor Nick Baker. And so he's the director of the Open Learning Unit there, like that. And he had actually, I've made a note here, the EdTech magazine listed him as one of the top 30 influencers. So I suppose he'd be making TikTok videos and something like that. But no, the three viewpoints represent a very good comprehensive analysis of generative AI and how we sort of deal with those issues. So
perfect. Yeah, thanks, Tom. So this idea for this hybrid event kind of started at the World Conference of Research and Technique in Athens that we were at in June when we saw Tomáš's talk, and then we knew about the work that was ongoing with Angela. And we knew work with Nick. So we said, look, it'd be great to maybe put together these 3 speakers to have this hybrid event. So that was the idea. But I mean, these ideas need support. And we're very thankful that we have in-tutor supporting for this event. And that's very important to acknowledge that. And you'll see in all of our outputs there that we have the in-tutor logo, because these ideas, there's a lot of good ideas that can be across all various sectors, but they need support. And we needed that funding for this event. And very much thanks to in-tutor for that.
So, from a very new technology to a very old technology, we have our graphic harvester, Maya Thomas, who's done work with us before, and she's logging in, so hi to Maya. And what she's going to do is try and capture in a visual form, and as you can see, she draws by hand. There's no technology here, except a black marker. But I think it's a nice way of capturing, and another way of capturing the insights and the thoughts and what people are saying. So each of the 3 speakers will be getting, there'll be a graphic harvest for each one of those, and that'll be one of our outputs. And as I said, I do think it's fitting from a very new technology to a very old technology. So she will just be capturing that as the day goes on.
Yeah, and we hope to share just, I suppose, the work in progress before the panel session after lunch. We share the work in progress for the 3 graphic harvests from the 3 speakers as well. And I think hope that well, we've worked with Maya before, we're well impressed, so I think no pressure on Maya.
No pressure on Maya there.
And look, then I think the next thing then just to mention, look, all the resources that are linked for today's event are available online. So if you scan those that are online here, you'll easily be able to scan this code up in the top left. Those in the room as well, you can scan it, and you basically have access to the agenda. I mean, we'll have it here, but introduction to I suppose the speakers that we have, the bio and the content for each of their presentations, and also there will be the link to Slido as well. So and we'll obviously have Slido up here as well. But and if anyone in the room online, maybe it'd be easier to kind of get access to this. But anyone in the room that may miss this, let us know, and we can come around and give you the QR code as well. Okay.
So, as I said, we've had a registration, our opening address, which makes it sound very formal. So our first speaker will be Tomáš. We'll then take a break. Then we'll have Angela and Nick, and then we'll take a break there. It gives us a chance to sort of, for Maya to sort of give a sense of her work in progress, and then to just formulate a couple of questions. But I think one of the things, hopefully, is that we'll be gathering feedback both online and in the room, and just to have a panel discussion there. And we really encourage people to sort of pose those questions. So we'll have our panel discussion in the afternoon then, and then finishing up with then at 2:30.
Perfect, thanks, Tom. And so when it comes to posing questions, there is a platform set up with Slido. So if you wanted to scan this is how we can, I suppose, engage with everyone equally, both in the room and online. So there will be a couple of questions posed by the speakers throughout today. So this is how you can respond to the questions. There's a couple of open-ended ones as well, and then there's obviously the opportunity for you to ask your questions, and they can be posed to the speakers at the end of their presentation. Each speaker will have time to address any particular questions, but obviously the panel session as well. Yeah. So we very much encourage you.
And the QR code, or just go on to slido.com and type in the number, it'll take you there like that. So
okay, perfect. And we actually have two questions.
We have 2 questions to kick off. So of course, we just get a sense of where people are at. what is your current role? So they're just to get a sense of where people are at. Let's see who's here.
So this just helps us, I suppose, get a sense of who we have in the room and who are online, and it kind of help inform the speakers as well.
Yeah, that's a sense. We seem to have a good flow. I love doing these live events because it's moving up and down, so you get a sense there. So people are just joining in, and so no, it's just a useful thing for us to get a sense here. And I think I'm delighted to see there's a good spread of different participants here today. Like waiting for a kettle to boil, isn't it? Sort of people logging on.
But I actually, for those that may be online, or when you're looking at the screen, if you didn't get the code, or in the previous one, you see that the numbers are up here, 5359517. So if you go to slido.com, or anyone in the room goes to slido.com, you can type in those 7 numbers, and that will give you access to this poll. So 5359517.
Yeah.
Yeah, we're good. You have to look. Look. I know. I understand that not everyone might have had time to complete it yet. It's just to kind of give a sense of what I think that we had that there.
Yep.
Happy to move on to the next one there. So,
yep.
Sinead, please.
This is an interesting one, and this is completely anonymous. IP addresses will not be collected. How would you characterize your current use of GenAI software? I don't use it at all. I've experimented with it a little. I use it fairly often, but not in a structured way, and I'm a regular and proficient user. That's interesting. Yeah, I think I would imagine a lot of people have experimented, as I said, whether they've done it in a structured way. Yeah, I think it's probably not. But as I said, 22% haven't used it at all, which is still part of it there like that. I suppose some of the things that I've sort of encountered is that, particularly with people who haven't really tried it, they either overestimate the capabilities of it or seriously underestimate. There doesn't seem to be a sort of middle point. I'd have to say, and just practicing and playing around myself and talking to other people who've been doing the level of the stuff that's coming out in the last few months, few weeks. Nick will talk about some of the stuff later on, and it's at the risk of hyperbole, it really is awesome and genuinely amazing. So yeah, I think it's quite sense there. So good stuff. I've experimented with it a little. It's almost half the people.
Super. So I think we're on to first speaker.
First speaker, yeah. So. Yep. So. As I said, no pressure on Tomáš, but he was one of the best speakers I've seen in years. And as I said, I think he unpacks the little black box in a way that makes it a lot more accessible. So without further ado, I'll pass on to Tomáš.
Thank you. Okay, thank you very much for a nice introduction. Well, not pressure at all, but I'm stressed already to fulfill your expectations. And I think that it's like with generative AI that people have too much high expectations, and then they realize that it's not as good as they expected. There are some downsides. So that's what I will be talking about. So first we start about how generative language models work. So look inside the black box. When I asked the GenAI tool Midjourney, that is designed to draw images, how artificial neural network looks like, it gave me this, which is not how the artificial network looks like at all. Yeah? So it's rather, there are different architectures, but it's something like this. And the important aspect that we need to understand before we start using all these tools is that it's kind of different paradigm from the programming point of view than in traditional programming. Like if you have traditional software product, it was designed and developed by programmers who actually wrote the code, so they can understand what's happening inside. They wrote all the functions, all the branches, cycles, database retrieval, queries, and stuff like that. Here in the AI tools that are heavily based on machine learning, the paradigm is different. The programmer doesn't write the code, but defines the program and then specifies the criteria. And so you specify the criteria to evaluate the quality of output. In terms of generative AI or the language model, the problem is, here is the seed, the beginning of the sentence, and give me the next word that would fit the best the current context. And you have some methodology to evaluate. You collect the data from all over the internet, so you can calculate probabilities of the words appearing in that context. And you have to train the model, you have to train the tool to provide the accurate output, which in this case is the most likely word in the given context. So one of the possible structures of artificial neural network looks like this. It's called multi-layer perceptron, and there is one input layer. So the input is always a vector of numbers. Yeah, the sequence of numbers, as well as output is also a sequence of numbers. And then behind there are these hidden layers of neurons. And each neuron takes the signal from all the neurons in the previous layer and sends the signal to all the neurons in the following layer. And all these connections have the waves, which can either diminish the signal or increase the signal. And that's what is being adjusted during the training. Yeah? So you start with some random numbers, you feed it with some input, get the output, and you compare the output with the ground truth, with what you expect. And based on the difference, you adjust the parameters in the network. And now you repeated it billion times, trillion times, and over the time, the parameters are adjusted, so the output layer produces you almost exactly what you want, or yeah, it depends on the quality of the model. But yeah, if you do it well, then the output layer produces what is specified, by the problem. So the model is built iteratively. You can train it like in several epochs, and yeah, we are talking about training or learning. For language models, the specific structure is a bit more complicated. Yeah, there's the feed-forward neural network is just one part, and there are some other parts as well. It's a concept that was developed in Google, published in 2017 in a very famous article, "Attention is all you need." So we can see it's not as old technology, but before that, we were basically not able to reliably generate the language, even though there were some attempts, but the technology reached kind of maturity only 7 years ago. And the transformers have two components. First, it's the encoding. So we take the vector representation of the input text. Here I use the word token, which is the basic unit of text. In English language, it's basically one word is represented by one token, but in other languages, it's a bit more complicated. In Czech language, you need usually more tokens for one word, which makes the computation then more demanding. And the vector representation is based on so-called word embedding, so the context of the words, and then it computes attention, which is relation between the tokens. I will talk about it in the next slide. So in the end, we have vector representation that captures the meaning of the input text. And then this vector representation goes to the second part, which is decoder. And the decoder, based on the input from the encoder and the previous output produces the text. So produces the output vector, which is then translated to output token, and users can see it as a text. And this basic structure is useful for many natural language processing tasks, like machine translation. You encode the meaning of the text in one language, and then you decode it in another language. Or paraphrase. Again, you encode the meaning of the input text, then you decode it in the same language, but using different words. Summarization, question answering, like a lot of different tasks can be performed by this structure, this transformer. So what is now a bit abstract is how you can represent the natural text, natural language as a sequence of numbers, as a vector. So this is called latent vector space, and it's also the feature that had to be trained. Here I am using the only two-dimensional simplification because the screen has only 2 dimensions, and in the room we have third dimension, but that's it. But the language models, they use thousands of dimensions. GPT 3.5, 8,192 dimensions. So each word or each token is represented as a sequence of more than 8,000 real numbers. And it was trained in a way that is able to capture semantic relations between the entities. So this is a very famous example. All these 4 words are represented by vectors, and you can then perform mathematical operations with the vectors. So if you take king, you subtract man from that king, you add woman, then you get queen. Because that's how it works. The relationship between king and queen is the same as between man and woman. And if you examine this further, like taking the vector between, let's say, Ireland and Dublin is the same distance or same direction as the vector between Czechia and Prague, Slovakia, Bratislava, Canada, Ottawa. It's the relationship known as being the capital of. So that's good because it also allows for multilinguality in the language model. We can also, if we travel somewhere else in the vector space to different languages, then the relationship, the differences between the concepts are still capturing the same features. And the words that have similar meaning tend to be close to each other in that vector space. So when this word embeddings, when the vector representations of tokens started to be trained, so the network had to figure out where to put each word. So let's now try it with this example. So we already have some sports here, some buildings here, some means of transport here, then we have some fruits here. So where would you put the word apple in this space?
6.6 or 6.5.
Yeah, somewhere here, close to the other to other fruits. That's pretty clear because it is more related to fruits here than to buildings here. But how about this case? We have fruits here, then we have some other things here. Where would you put the word apple right now? Is it apple as a fruit that I can eat, or is it apple as a computer that I can use as a technology? So that's not clear at all, and we probably put it somewhere between. And then context matters. So we have apple somewhere here because just from the word apple, we don't know whether it refers to fruit or to computer, and we have to take context into account. So if the sentence looks like I'm going to eat an apple and an orange, then obviously it's rather this apple. But if Apple released a new model of iPhone, it's obviously more this apple. So we have to make sure that the vector representation of the word changes based on the context. So we either pull the apple towards the orange, or we pull it towards the phone. And this is called attention or self-attention. There is some mathematics behind that basically transforms the vector space in a way that we have the words with similar meaning closer to each other. Yeah, so we say that they pay attention to each other, so that's why the technology is called attention. In practice, there are three matrices, like key queries, where it captures like for each word, for each token, like what other relations is it looking for, what keys, what attributes it has, and then the values it's specifically designed to adjust it to produce the next word. Yeah, so not only to capture the meaning, but also to produce the next word. So this is one basic unit. But one attention is not enough for more complex tasks. It would be able to just generate the text, but we want more from the GenAI tools. We want to capture some other features. Yeah? Sometimes we are more interested in syntactic relation, sometimes in semantic relation. We want to capture also general writing style, the dependencies that are close to each other, or long-term dependencies, and all this stuff. So the solution to that is so-called multi-head attention. So what I just explained happens several times, hundreds times. So there are several heads. All of them produce the attention, the matrix multiplication with key queries and values. So this is done in parallel, then the results are concatenated, and we are having one more complex unit. But even this is not enough. Yeah? For higher order cognitive tasks that we require from GenAI tools, we need even more blocks. So we need to capture more features. Yeah, so all this multi-head attention is part of this transformer, and then we have more transformer blocks, yes, series of transformer blocks, and each input is then processed through this series, and then we are getting the output. But all this stuff, all this complicated structure is there just to answer the simple question. Given the beginning of the sentence or given the previous context, what would be the next word? And it produces one token at a time. So after production of one token, the seed, the beginning, is increased by that word, and we ask it again. So you can see there is a lot of computation behind, matrix multiplication several hundreds times. And then this happens in each block, and there are multiple blocks. So the demand for computational resources is pretty significant. And this is inside the GenAI chatbots that most of you already experimented with, like ChatGPT, Google Gemini, Claude from Anthropic, or Llama from Meta. And they are adjusted not only to generate the text, but to have meaningful conversation, to answer questions and solving more complex tasks. But basically, having the conversation is just that's fundamentally the same problem as producing the next work. Because if you have the seed, hello, how are you? So then what will be probably the most likely continuation? Fine, thank you, and you can have this conversation. So it's the large language model, and then there are some additional layers. First is nice user interface, so the interaction layer that allows you to answer the question, and it gives you the answers. You can see the history of all the conversations and stuff like that. But there are also some things that are that have ethical relevance in scientific context. Moderation and safety filters that are screening for harmful, offensive, sensitive topics in users' input. Have you already experimented with asking it something that would be like illegal or something? Like my students, I'm teaching the course Ethics and IT, and since the ChatGPT was released, like every semester, I give the students the task. Choose some course that you already passed, that you already completed, and try to solve the tasks with ChatGPT. And especially the students who choose some cybersecurity course and ask it to produce some kind of malware, that they are struggling with getting the answers. Hey, they refuse it. Hey, I'm not going to give you any malware. But I'm a student. I need to learn how the malware works to be able to prevent it. Okay, here is the code. So it's that there are some way how to persuade these filters that you get through. Then there is request routing and tool invocation. Not all the questions go directly to the language model to retrieve the answer. Sometimes you have to look up the internet. Sometimes there are calculations involved. This was one of the issues that early versions of ChatGPT suffered from, that it was hallucinating numbers. So now it can recognize that we are asking for some computation, and it generates the Python code, interprets the Python code, and gives you correct results, which is quite specifically useful in statistics and math and so on. Or image generation, you may ask it to generate image, so it doesn't go to the language model, but to another language model that is connected to image generation tool. And then, because the designers know that what is inside of the language model that was trained on all the data from internet, containing all the bias and all the nasty content, that sometimes you can get things that would be better not to produce to users, but to filter it out. So there is again output filtering. Another screening for harmful content. So a lot of layers, a lot of computation. The large language model is only part of that tool, and the tool has to handle much more complex issues. I introduced the transformer architecture, which can be used for both for transformation, like translation, paraphrasing, summarization, and this stuff, and for text generation. From the point of view of both educational integrity and scientific integrity, when we want to use it to produce the content that we are further using in our work, it's important to distinguish whether we are just transforming something that we already have and we uploaded it to the tool. So the language model is fed with already existing text, research paper, or our paragraphs that we just want to reframe. And the task is to transform the text into another form, translation, summarization, and so on. Here, the risk of hallucination is quite low because it just works with our text that we have provided. On the other hand, text generation, the language model has no other information, just the prompt, just the start of the sequence or the question, and it has to produce the content, generate the text. So it's just kind of average of all the training data of all internet, the most likely words that would appear in that context, and it doesn't have anything to do with factual correctness. So here, the risk of hallucination is much larger. So that was the technology behind. I'm not sure, are there any questions in Slido? Was it understandable?
Yeah.
Okay, good. So where are we now, and what can we expect from future?
Can I just ask about the previous slide?
Yeah, sure.
If the seeds or the prompt is very basic, is there more chance of hallucination? If you wrote a very detailed prompt, is it less likely to hallucinate? Or
It is more likely that you get what you want if you provide a prompt with more details. If you provide just the general prompt, very short one, the information it has is really small, so it will be more influenced by the model as such. The longer the prompt is, the more information it has, so the risk of hallucination is smaller, but it's still there.
Tomáš, sorry, there is actually one question just come in there.
Yeah.
I'll call it out now, and sure, if it's not, if you prefer to wait to the end, that's fine. So the question was, why use softmax function in Transformer?
The softmax function is here if you have the probability distribution. So that's what the neural network gives you. So over all possible tokens, over all possible words that you can put there, it gives you the probability. Probability that that particular token fits in the context. And then the softmax function takes the most likely one. If I simplify it, so it transforms the output from the neural network to the softmax function transforms the output of the network to the probability distribution. So then there's another parameter in the language model called temperature. So it regulates how diverse the output will be. So you either take only the most likely word, or you have some range, and based on the probability you are choosing from more words. So that's why the softmax is there, because you need the probability distribution. This curve, it's called hype curve, and I took it from Gartner consultancy company. They produce this hype curve for every technology, every new technology that appears. And in July this year, they published this hype curve for generative artificial intelligence. And it is always this shape. So first, when there is an innovation, people have high expectations. So something new appears, and the expectations that skyrockets there, and people think that this will solve all the problems that we have. The teachers won't be needed anymore. Students will have this GenAI teachers, and we don't need the lawyers, and I don't know, the project managers and whatever. We can just relax because the GenAI will handle this for us. So this is a peak of inflated expectations. Then people realize that it's not as optimistic. They thought in the beginning there are some drawbacks, probably the fundamental and significant drawbacks. and the expectations go down to so-called truth of disillusionment. So everybody thinks that technology sucks and is not useful for anything. But in the meantime, the developers work on it and improves that, and there are still some use cases where the technology is good for. So then, through this slope of enlightenment, people in general find some useful use cases for the technology, and then it stabilizes. It happens with everything. Yeah, it happened with internet. People had overly large expectations, then there was this disappointment, and now it's kind of stabilized. We know what internet is good for. We also know the risks, and in all areas it's stable, and we can productively use that technology. Large language models are currently here, so we are already behind. According to Gartner, we are already behind this peak of inflated expectations, and we are now going through this, going to this trough of disillusionment. So we can expect disappointment and bad reports about how harmful this stuff is. Yeah, but it's this light blue dot. So in 2 to 5 years, we can expect reaching the plateau of productivity. And I would say I agree with their prediction. Yeah, that's what we have now. So it's almost 2 years since ChatGPT has been released to public. So a lot of people are now building more applications based on this language model. So the development is going pretty intensively, and we will see what it will be good for and what not. Recently, one AI company even presented the prototype of the AI scientist. AI scientist, so it's a piece of software that can do all the phases of research process automatically. So it can generate the idea, so basically hallucinate something, but then check the novelty using semantic score or other databases of scientific literature. Then it can design the experiment that would either prove or disprove some hypothesis, especially in the field that you can experiment just by running some software like computer science. It's quite useful. So it can produce the code, execute the experiment script. So there might be several iterations, and then you have some numbers, you have results from the experiment, and it can write a paper based on that result and even provide the review. And all this process, yeah, of course, has some computational costs, but it's like $15–20, something like that. You pay for the licenses to the language model or for performing the computation, and then you have the paper. Yeah, but having the paper for $15–20, it's quite a good deal. But the question is how these tools, how reliable these papers are. And now we are getting to the ethical challenges in scientific context. Is there a risk that the scientific literature becomes flooded by these artificially generated papers or not? I will be talking about the working group that we have in the European Network for Academic Integrity that is dedicated to technology and academic integrity. If you're not familiar with this association, it is an association of universities and also other institutions, and we support our members in the field of academic integrity. We facilitate experience exchange, we organize conferences, webinars, summer schools, and so on. And academic integrity encompasses both educational integrity and research integrity in our view. So we discuss a lot these issues, and our view is that the wide availability of generative AI doesn't bring any new threats in principle. It just exacerbates existing threats to academic integrity. In educational point of view, ghostwriting or assignment outsourcing, students have been buying essays or theses from companies or their classmates for decades. Now it's more obvious with generative AI, but it's the problem that existed even before. And last year, we published the NI recommendation on ethical use of AI in education, which was published in the International Journal for Educational Integrity. And this year, we are dealing more with the ethical challenges in science. So what is in our recommendation for education? First, we state some context. So we have the tools now that can be used to transfer, produce, or generate basically any kind of content. It's not only about text, it's also about images, art, programming code, whatever. Yeah, basically any output that we want from students to complete the course can be generated by AI. And it's challenging, technically even impossible to reliably distinguish AI-generated content from human-produced content. So even though there are some AI tools that can do that, but it's always just this AI thinks that the text was produced by another AI, but there is no evidence. So it's not useful in disciplinary procedure or any kind of procedure. And we can't prevent students from using AI. There were some attempts that some universities banned ChatGPT to be used in their network, but we know that this doesn't work. The students have internet connection even at home. Surprise! They are not depending on the internet provided by the university, so they will be using that. They are using it, and it exacerbates existing type of threats. Yeah, I already said that. So for education, we tried to set the borderline of ethically acceptable use of AI. And in education, it always depends on the purpose of the task. I like to compare it with calculator in math and math teaching. For pupils in the first or second grade, where they need to learn how to perform addition and multiplication. Of course, if they do their homework with calculator, they don't learn anything. But in secondary school or even at the university, where the focus is on other things, like making some calculations with calculators are okay, because it helps them to focus on the current task and not waste the brain capacity by doing the calculation. So and with the GenAI is the same. The purpose of the task should be clearly communicated to students, and then authorized and declared use of AI is generally okay. Where here it is conjunction, both authorized and declared use of AI is okay. But if it is either unauthorized or undeclared, then it is academic misconduct. And we basically generalized our definition of contract cheating or ghostwriting. So production of academic work for credit, progression, or award, whether or not payment or other favor is involved, using unapproved or undeclared human or technological assistance. And so it doesn't really matter if students outsource their tasks from a person or from a machine. Then the question is, what should be acknowledged? Where's the borderline on what should be acknowledged and what is okay to use without the need for acknowledgement? And our recommendation is that whenever it influences the content or ideas, it should be acknowledged. So consequently, the AI tools, if they influence the content, they should be acknowledged. So the form may differ, depends on the task and the context. But if the tools only influence the form, it is generally accessible. So proofreading tools, spell checkers, and so on. But in general, of course, in specific language learning tasks, even these tools may be not appropriate, but in general, this is fine. So, does this requirement apply also to science? Do you agree that the use of GenAI in any scientific activity should be always disclosed? Let's go to Slido. Yeah, or the other one? Or...
Second right.
This one?
Yeah.
Oh, the Chrome
Yeah, see the one to Chrome.
bottom line, second from the second.
Oh yeah, here, this one. Yeah. Okay, sorry. So here's the statement: the use of GenAI in any scientific activity should be always disclosed. Do you agree? Okay, I will be neutral. So it seems that majority of people here agree, or even strongly agree, that any use of AI in scientific activity should be always disclosed. Yeah, I deliberately put this like extreme statement, like any use and always disclosed. Okay, so let's move to the next question. Imagine that you are reading a scientific paper, and then you learn that the GenAI tool significantly influenced the content. Will you trust the results less? Neutral again. Okay, now it is not so. But yeah, it's, agree, strongly agree. Yeah, most the largest number is here, agree. But if you sum up agree and strongly agree, it's like 3/4 of people. And yeah, this was quite expectable. So we agree that that use of GenAI should be disclosed, and we also then become more suspicious. Yeah, we trust the results less. So those who follow the rules, those who obey the requirement and declare using of GenAI, they are disadvantaged. The dishonest people who use GenAI and not disclose it don't risk the loss of trust and actually have this unfair advantage, which is not good. We also know that the outputs can include biased, inaccurate, or incorrect content that users should be aware of. So it puts much more emphasis on responsibility. There are now already the disclaimers that you should not trust the content. Yeah, the ChatGPT or the other models that they say that it may hallucinate, confabulate, or other things. So they don't provide the responsibility for the generated content. There is always disclaimer that it's up to you what you do with the content, and you as a user are responsible. So this is also the reason why an AI tool cannot be listed as a co-author in a publication. And basically, this is the only statement that the whole scientific community, or almost the whole, agrees on. Yeah, that AI tool cannot be among the authors. It's based on the criteria of authorship from the Committee for Publication Ethics, that there are four criteria for authorship. First is a substantial contribution, then drafting or revising the work, and final approval of the version to be published, and agreement to be accountable, taking the responsibility for all aspects of the work. And even though the GenAI tool can substantially contribute, can draft or revise the content, it can never approve the manuscript or whatever it is, and it can never accept responsibility. So it fulfills only half of that four criteria. So we are moving more to the ethical issues. There are some general issues that are related to using large language models, training and using large language models, and not specifically about the science. It was recently published by people including Tim Gebru, the former head of AI ethics unit in Google. So they thought thoroughly about the ethical risks. First, it's the energy consumption and carbon footprint. I told you how, what kind of computation has to happen until you get one token. So you can imagine that only using this tool consumes some energy and provides and produces some carbon dioxide emissions. And for training, it was even worse. Yeah, to train GPT-3 language model, it had the same carbon footprint as one jumbo flying across the Atlantic there and back, which is not as bad. Yeah, this is something that happened like, I don't know, 100 times per day. So having a language model is kind of beneficial for the society, but it's still there. Digital divide is also an issue that is discussed. There are certain category of people, like all of us here, who can afford it. We have mobile phones, we have computers, we have access to this technology, but most of the population of the planet don't have access to that technology. And ironically, these people are those who will most suffer from the climate change and the consequences of the carbon emissions. So this is something that is called environmental racism, that the rich part of the planet uses the technology, and all the consequences, all the damages are on the poor part. Societal changes in labor market. GenAI will significantly change the structure of professions. Then impact on individuals. Like with any technology, if we rely too much on that, we are depending on technology and lose the ability to solve the tasks by ourselves. Then biased training data, which is manifested in biased outputs and reinforcing stereotypes, hallucinations, confabulations, which leads to inaccuracies in scientific outputs. And then the black box problem, even if we know the structure of the neural network, we know that there are some neurons with signals, we can't really say why the parameters are as they are, and explain the result and reproduce the result is really difficult. Yeah, so these three issues have particular consequences in scientific work. 5 minutes. Okay. So, what are the tools that we may use in scientific work? There are tools for literature gathering. There are the language models connected with search databases. So there are plenty of them. They can summarize the abstract and provide some overview in the field. So if I ask how accurately can we detect the text generated by AI, it can give you the summary of some papers, including the study that we have done in our working group and some other studies. Consensus, it's another tool for yes/no question. It can give you some meta-analysis. Yeah? So if you ask it whether the human activity influenced the Earth climate, you learn that yes. For the vaccination on autism, the answer is not so clear. But it sometimes don't read the text correctly. Yeah, here is the typo, not associated with autism, and it's labeled it yes because there was didn't read that not correctly. So we have to be careful about the interpreting of the results. So every phase of the research process has some potential ethical issues that we should be aware of. I'm pretty sure that Nick will talk about it more in detail, so I'm not going to steal his topic. And since we are now running out of time, I will also skip some part, but that doesn't matter. Yeah. So in all phases, there might be some misleading information. So you can identify the literature. There is a risk of getting unreliable sources. Then there are tools like ChatPDF or some summarization tools, which we also experimented with. And sometimes you get the hallucinations that you can't really understand. I uploaded our paper that we wrote, and I asked who are the authors. Here is the reality. These are the authors. So, and this is the response from the tool. Yeah? So it correctly identifying me, but all the people here, or almost all, are like completely hallucinated or attributed to wrong institutions. So it was like a nonsensical answer. When you ask it to generate some code you need for data analysis, for example, you have to also be careful. You have to check the code, check the output, because sometimes it gives you the wrong code. So you say, hey, this doesn't work. Oh yeah, apologies for the oversight. This is the correct code now. Oh, it's still not correct. Oh yeah, I'm sorry for that. Yeah, we don't have the time for experiment. If you imagine a scientist, but it reinforces the stereotypes. If you ask the language model or the image generating tool to imagine a professor, you get always these white males. If you ask it to depict artificial intelligence, it's kind of the submissive assistant role, so you always get women. If you ask it to draw a family meal, you have Thanksgiving meal, even though there is some diversity, and there are some dark-skinned people, apparently from Middle East, but eating Thanksgiving turkey. So the cultural biases are there, which is quite understandable. Because people are sometimes pointing out these stereotypes, so the developers try to introduce some diversity, which has sometimes some funny consequences. Yeah, you ask, hey, give me the illustrated image of 1943 German soldier. So you are getting German soldiers. Some of them are women, some of them are black or Asian types. So yeah, not always the diversity is appreciated. So it's really difficult ethical dilemma, the borderline between how our work looks like and how it is reflected in the language model. This is one way, and like reinforcing harmful biases is second aspect. We want the language model to reflect precisely our world, but we don't want to reinforce these stereotypes. But our world is biased, yeah? Or at least the texts that were used for training were biased. Sexism, racism, violence, everything was there, and now we want the models not to produce that. But it's mostly the same as human scientists. Human scientists also produce inaccurate and misleading outputs. Humans are also biased. So need for thorough check and verification of outputs is there, no matter if it was produced by AI or people. It maybe creates more need for education and training. We know that lack of knowledge is one of the causes of scientific misconduct. So there is a need for scientific integrity trainings. There have been some Horizon projects that produce a lot of materials. There are maybe some AI-specific issues that should be introduced to these trainings. Copyright issues, both about uploading material and generated output, data protection and privacy becomes more important than it was before. And there are some systemic problems in science. Yeah? First is quality of review process, which is now not sufficiently rewarded depending on voluntary work. So sometimes the reviewers tend to outsource it from PhD students or do it as quickly as possible. So sometimes even in high quality journals, the rubbish gets through. And if the review process becomes more overwhelmed with the AI generated content, the challenge is really strong. Yeah? It may overload the reviewers. And evaluation of scientific output, which is heavily based on quantitative criteria, and it's basically then incentive for production of AI generated paper. So coming to the conclusion, the inaccuracies, bias, this is same for humans and AI. Training is needed in scientific integrity, maybe introduce some new topics because of AI. And we still need to address the systemic challenges that create the incentives for misconduct. But again, this is something that have been discussed for decades with no reasonable conclusion so far. So it's nothing new in principle. While accessibility of AI just exacerbates existing threats, but the good news is that now there is quite intensive discussion around that. These problems are more visible than they have been before, and it may accelerate solutions. Thank you for your attention.
Thanks very much. Thanks, Tomáš, for that. It was great to kind of get the background to it, as Tom said here, to kind of know what's inside the black box as well, because we can sometimes be aware, or hopefully we're aware of some of the ethical issues or the integrity issues with it, but maybe the why, the ethical issues or why that's actually happening. Very, very useful. Now, thanks very much. A question kind of came in from the chat there in the Slido. So again, anyone in the room or online, if you wanted to post a question, please do using Slido. So it was going back to the polling that you used there, which was interesting to see how the distribution was. But anyway, a participant here says, I agree that this creates incentive to not disclose, but I would also argue that someone who uses it and doesn't disclose for this reason would be trusted even less.
Yeah, the discussion that I'm having with colleagues or participants of events like this usually leads to the conclusion that the best way is to disclose it, not only in the general way, hey, I use ChatGPT to improve my paper, but specifically say what exactly was it used for and how. So even the reader can get the impression whether it could influence the credibility of the paper or not. And then if you acknowledge the limitations properly, so everybody can see that you are aware that it's not perfect, this is the way how to avoid the loss of trust while fulfilling the general requirement of acknowledging properly the use of GenAI.
Super. And then another question just came in there. So I was just interested in your own views to using GenAI in publications, and would you be supportive of its use?
Yeah, I would be supportive to a certain extent. Yeah, of course, generate a paper for me, it's not an ethical way. But for me, as a non-native English speaker, it's sometimes inevitable to use these tools, at least grammarly, for as a spell checker, but even, hey, this is the paragraph, I need to sound it more more convincing or more scientific, rephrase it. So sometimes it uses the words that I wouldn't use. So for me and for all non-native English speakers, this is better. So it can also increase equity in this area, that we are not so disadvantaged in the English-speaking environment.
I suppose.
Do we have a question here in the room?
Yeah, brilliant. Go for it.
Or a comment where that bit very interesting is I was reading over the week that the author Claire Keegan, who's in the news, I read small things like these there 2 weeks ago, and the flow was just amazing. You can just read it through with it. There's no lumps or bumps. It's like a car that's kind of, it's been fully panel beaten and every like imperfection hammered out or needed out maybe. But if you think about it, and I've used ChatGPT at times to kind of do first draft of a letter or whatever like that at times. And then, but I find I love having a first draft, and then I put the on and behave on it after that and the style and all that. But actually, if you think about it, you know, where like in terms of literature and so on, that's that kind of piece. Then, if you're going to put your draft for a novel into it and run it through to smarten up the English, and as these tools get more sophisticated, you know, where does the Claire Keegan versus the AI tools sit? It's kind of fascinating listening to it, and possibly similarly in music as well in time to come. So it's just kind of, I don't know if there's any thoughts on that. It's just getting, it's very challenging.
Yeah, I keep being surprised sometimes by the abilities, like what it is able to do, how complex tasks it is able to process. It would be accepted to our university. I try to do like master the entrance exams to our master study programs, and it would get 38 out of 40 points.
And the point was, sorry, was that I think this author like completely we drafts to knock out everything in the same way we do with policies. But if you could just, you know, it's sort of. It's kind of one thing to do for a policy, but to do for it's where it's an author, it's kind of it kind of brings questions of ownership then.
Yeah, it's like having the
usage or
No, she does not have to make that very clear. What I read is that she drafts repeatedly, and what I found when I read the book was I just was able to read it through. I'm reading another book now at the moment where, you know, there's little things lost in the editorial, where to flip back and see. Did I miss that or something? This book just, I read, I've never experienced a thing where I just read it through an hour and a half of the train journey, and it just flows so well. And what I heard afterwards is that she drafts and drafts and drafts and drafts. And, you know, I was doing something similar to the other day in terms of like draft, you know, you sit down a draft procedure for 2 weeks and then you look at it again and you see there's little pieces you forgot, or you forgot to put in a provision, and you suddenly realize, and if AI could do that for you, that's one thing, and it's something kind of personless like a policy. But if it's a novel by Claire Keegan or by Richard Nichols or whoever, it kind of throws up huge questions, or even makes music as well.
Yeah, like in all areas, it's like having the personal assistant that produces the work for you on your behalf, and it's more and more capable. Like every week, it's getting better.
But even what like writers in a way are doing what ChatGPT does, like they're drawing on a data set that they have, and all the books and the writers that they've written, they're like harnessing those ideas and the sentence structures and setbacks to write what they're writing anyway. So in a way, it's like synonymous, just bigger data set than AI. Anyway.
Look, there's a good few questions that have come in there through Slido, and look, I won't. We'll ask one here, but the rest I think some there would be actually quite useful for the panel discussion. So rest assured, like your question here will be actually addressed by just if not now, which it won't be, not all of them now, but then the panel discussion we will raise them for sure. But maybe just one, because I think it links in with using it for kind of the research purposes, the GenAI. So what are your views about using GenAI tools for summarization of papers to have a broader literature review?
This is a task where the risk of hallucination is lower. So sometimes I use them, but you have to be aware that it's not perfect. It's like asking, let's say, the master student, hey, this is the paper, please summarize it for me. So he or she can do the good job, but also there is a risk of not capturing some important issues, and we saw this in our experiments, that sometimes it did not retrieve the information. And actually, what is interesting, these language models suffer from similar drawbacks as humans. They can remember things from the beginning and from the end, but if something is mentioned in the middle, they tend to forget it. But it's the same as humans reading the documents. So if it is important source for your work, I would always recommend to read it by yourself.
I think maybe this is something for the panel now when we have after all the presentations, but where's the bar or where's the line to we note that GenAI has been used or we don't? Do you know, if we just use it as for a quick search, is that noted in our output that we've used GenAI? Or if we've thrown in a paper to get it summarized, do we acknowledge GenAI then? I think, like, where does that bar, where is that? And look, obviously that's where the discussion is happening internationally as well, you know, but maybe that's something to get the three speakers' thoughts on in the panel discussion. But I think for the moment, thanks very much, Tomáš. That was really interesting talk. I know it's always a challenge being the first speaker up, so thanks very much. You did brilliant. And we'll take a short break. So the plan here, so I know that there's participants online that would not necessarily be working from Irish Standard Time. So we're going to take a break and we'll come back at 1/4 the hour. So whatever your hour is, we'll come back at 1/4 then. And so I know we've got over the time, but we've allowed for that, but we will start on time for the next one. So 1/4 the hour. Thanks very much, Tomáš.